Successfully securing the mesh to the abdominal wall is key to a long-term durable repair. With more than 5,000 resorbable polylactic acid microgrips over the entire mesh, ProGrip laparoscopic self-fixating mesh is a uniquely innovative product that combines mesh and mechanical fixation into one device. As a result, ProGrip laparoscopic self-fixating mesh delivers tack-free fixation over the entire anatomy, including below the inguinal ligament where tacks, straps, and staples cannot be placed. This video provides a side-by-side comparison between ProGrip laparoscopic self-fixating mesh, Bard soft mesh fixated with Bard Sorbifix tacks, and Bard soft mesh fixated with Baxter Tissio Fibrant Sealant, subjected to increasing levels of pressure and a bench testing to determine which combination provides the best fixation. Each mesh was oriented over a simulated medium-sized direct inguinal hernia defect. The peritoneum was then placed over the mesh to create a seal. Each mesh was then subjected to the same levels of pressure. As you can see, there is a sudden increase of pressure. Each mesh is placed under stress and is invaginated into the defect to some degree. As the pressure is steadily increased, notice how the Bard mesh fixated with Sorbifix tacks is the first to fail at 195 millimeters of mercury. Soon after, the Bard mesh fixated with Tissio glue fails at 280 millimeters of mercury. Finally, turn your attention to ProGrip laparoscopic self-fixating mesh. Even as the pressure is increased to 470 millimeters of mercury, which far exceeds the maximum intra-abdominal pressure, the PLA microgrip fixation prevents the mesh from failing and re-exposing the defect, validating the fixation strength and tenacity of the PLA grips. As the pressure is gradually decreased, notice how the ProGrip laparoscopic self-fixating mesh returns to its original position, ensuring that the mesh correctly overlaps the defect. Let's now take a look at each video individually and see how the pressure and subsequent fixation failure relate to daily patient activities. First, let's review the behavior of Bard mesh fixated with Sorbifix tacks. At 195 millimeters of mercury, which is less than the pressure generated by a jump, the top right tack is pulled into the defect, subsequently causing the mesh to be pulled into the defect. The failure of Bard Sorbifix fixation and subsequent re-exposure of the defect at 195 millimeters of mercury could potentially lead to recurrence. Next, let's review Bard mesh fixated with Tissio glue. Initially, the mesh is able to withstand the gradual increase in pressure, but as the pressure reaches 280 millimeters of mercury, which is only slightly higher than the intra-abdominal pressure generated by a jump, Tissio sealant fixation fails and the mesh is pulled completely into the defect. The failure of Baxter Tissio sealant and the subsequent re-exposure of the defect at 280 millimeters of mercury could potentially lead to recurrence. Lastly, let's review the performance of ProGrip laparoscopic self-fixating mesh. Even as the pressure is increased to 470 millimeters of mercury, which far exceeds the maximum intra-abdominal pressure, the PLA microgrip fixation keeps the mesh in place and prevents the defect from being re-exposed, validating the fixation strength and tenacity of the PLA microgrips. As the pressure is gradually decreased, notice how the ProGrip laparoscopic self-fixating mesh returns to its original position, ensuring that the mesh correctly overlaps the defect. Although there are several methods for fixating a mesh, including tacks, glue, and PLA microgrips, this video confirms that PLA microgrips provide superior fixation strength in comparison to Bard Sorbifix tacks and Baxter Tissio Fibrant Sealant for laparoscopic inguinal hernia mesh fixation.